In the last lesson, we discussed the primary controls, but there are a lot of other knobs and switches in this cockpit. What do they do?
This would be a good time to talk about some of the secondary controls, like the flaps and the trim. Secondary controls allow us to optimize the performance of the airplane for particular phases of flight.
Unlike the primary controls, some secondary controls may not even be present in simple aircraft. During your check ride, you'll be expected to correctly use whatever secondary controls are present in the aircraft that you're using. As you progress as a pilot and you fly different aircraft, you'll need to know how to use additional types of secondary controls. Trim is used to relieve control pressures on the primary controls. Flaps improve the wing's performance at low airspeeds. Spoilers, sometimes called air brakes, are used in aircraft with very low drag to better control descents. Retractable landing gear improves an airplane's performance at cruise speed.
Since we leveled off, I need to keep pushing forward on the yoke. Every time I relax for a moment, the airplane climbs.
You need to use the trim wheel to get rid of the control pressure. That will make it much easier for you to maintain altitude.
When you make a change to the airspeed or change the airplane configuration, you will often notice that you need to maintain some force on the yoke or the stick in order to stay at this intended airspeed. So why is that a problem? Well, in addition to the fact that your muscles tend to get tired after a while, we also tend to relax that control pressure whenever we focus our attention on something else, and trim allows us to change that neutral position of the control. By neutral position, I mean the position that the control would move to if we just let go of it. We can use trim to avoid the need to hold control pressures for long periods. Most aircraft have elevator trim. When you change flight conditions, you should adjust that elevator trim so that you're neither pulling or pushing on the yoke or stick. Some aircraft also have rudder trim and/or aileron trim, but that's not very common in training aircraft. Different airplanes use different mechanisms to accomplish elevator trim. One mechanism is changing the position of the leading edge of the horizontal stabilizer. Changing the angle of incidence of the stabilizer changes the pitch attitude. So if you want to keep the pitch constant, you'll need to move the control as you move the trim. You may also notice that the trim position changes the maximum amount of elevator authority that's available. Another mechanism is called an anti-servo tab. When the anti-servo tab is deflected down, as shown in this photo, the airflow deflects the elevator upwards. An advantage of this arrangement is that moving the trim does not change the pitch attitude or the elevator authority. Only the force on the yoke or the stick changes. The last mechanism is a spring arrangement, which directly puts force on the controls themselves. The cockpit controls for trim are not standardized. You may find a trim wheel, like the one pictured here, mounted on the console or the instrument panel. Notice that there's an indicator next to the control, which indicates the current position of the trim mechanism. This is useful for setting the trim before takeoff because the normal method of trimming away the force on the controls doesn't work before the airplane is moving. Another cockpit control that you may find is a ceiling mounted crank like this. These are just two examples. You may encounter others also.
Now that we have slowed down to traffic pattern speed, I will lower the flaps to prepare the airplane for landing.
When you lowered the flaps, the amount of force I need to apply to the yoke changed. I'm glad that you taught me about trim.
Some airfoil shapes are great at high speed, but not very good at low speed, while others are good at low speed, but they're not very good at high speed. Flaps are movable control surfaces on the trailing edges of the wing, which allow the pilot to change the shape of the airfoil to a more cambered shape based on the phase of flight. Flaps are usually located inboard of the ailerons. The pilot extends the flap in stages. The most significant effect of the first couple stages of flap extension is an increase in the maximum lift coefficient. That decreases the stall speed of the airplane. The later stages of flap extension tend to increase the lift coefficient some, but mostly they increase the amount of parasitic drag. The manufacturer will specify a maximum flap extension speed. Since the lift coefficient increases when you extend the flaps, the airplane will start to climb and slow down. If you don't want that to happen, if you want to stay at the same airspeed, then you'll need to pitch down slightly as you extend the flaps. Some aircraft have manual flap controls. These take the form of a lever. The pilot pulls up on the lever to extend the flaps. You'll need to push a button on the end of the lever in order to release the lever and let it move between the various detent positions that correspond to different flap notches. With manual flap controls, it's possible to extend or retract the flaps very quickly. There are some conditions where that's a useful thing to do, but there's also conditions where that's a dangerous thing to do. So in general, it's best if you move the lever gradually, one notch at a time. Other aircraft have electric flaps. When an aircraft has electric flaps, the flaps are moved by an electric motor, and the pilot controls that motor using a switch in the cockpit. With the switch that's shown in this picture, the pilot puts the switch in a position that corresponds to the desired flap setting, and then the motor runs for as long as it needs to in order to move the flaps to that position. After you move the switch, it may take several seconds before the flaps are actually in the selected position. In other airplanes, the switch just has an up, down, and neutral position, and if you want to select a partial deployment of flaps, you would push the switch down, and then you'd count off, 1, 1000, 2, 1000, 3, 1000, and then switch the switch back off again.
So, now we have talked about the flaps and the trim. There are still a lot of other switches and knobs that we haven't talked about yet.
Those controls are associated with other systems, like the engine, the electrical system, or the fuel system. We will learn about those controls when we learn about those systems. There are a couple other types of secondary aerodynamic controls that we don't have in this aircraft.
Spoilers are controls which extend above and sometimes below the wing. Sometimes it's a plate like the one shown here, other times they're hinged. They increase the drag and they reduce the lift. So you may wonder why you would want to do that. Well, on aircraft with very little parasitic drag, spoilers are useful for controlling a descent. So in gliders, spoilers are used to control a descent the same way that power is used in a powered airplane. There are some aircraft that use spoilers for roll control. They either use them instead of ailerons or they use them to supplement the ailerons. When they're used for that purpose, then the spoilers will deploy on only one wing at a time, whichever wing you want to lower. Most likely, the aircraft that you're using for training has fixed landing gear. However, as you progress to other airplanes, you're likely to encounter airplanes with retractable landing gear. Airplanes that are designed for fast cross-country travel have retractable landing gear in order to reduce drag in cruise and improve cruise speeds. Obviously, it's very important to make sure that the landing gear are extended when you're landing. Some airplanes are designed to operate either from a runway or from water, like a lake. Having the wheels down when you're landing on the lake can cause the airplane to flip over. So it's very important in those to position the wheels correctly for whichever type of surface you're going to land on. For aircraft that have retractable landing gear, there's usually going to be a maximum speed for operating the aircraft with the landing gear extended. There also may be an even lower maximum speed for changing the position of the landing gear.
Now that you are familiar with the primary and secondary controls, you know how to control the airplane in flight. Once you learn to control the airplane on the ground, you will be ready to learn about takeoffs and landings.